Hello and welcome. My name is Anthony and this is Fluorescent Learning. Before we get into the actual video, the last video I said this video would be about functions and modules, but I want to try something different. So for this video it'll just be functions. I think I'll start, each video will just be one full topic. That way it's not too much of an information overload. Alright, let's learn. In this video we'll discuss functions, their returns, arguments, using an arbitrary number of arguments and keyword arguments, local versus global variables, recursions. Then we have 2 exercises and we'll finish it off with a project. So you may be asking, what is a function? Well, a function is just a reusable block of code. So instead of writing 5 lines of code every time we want to do something, we can put those 5 lines into one function, and then anytime we want to do those lines of code, we can just call the function. Way easier. Let me show you what I mean. So let's make a new file. We'll call it functions.py, and let's make a function. Let's say I wanted to take an input from the user and greet them with a message saying hello and whatever the name is they give. Let's try it the old way first, without a function. So create a variable name. I'll give it an input saying what is your name, and then I'll print using an f string. We'll say hello, we'll input their name, and then we'll ask how they're doing. Alright, let's see how this works. Just these 2 lines of code. What is your name? I'll say Anthony. It says hello Anthony, how are you doing? Doing great. Okay, let's say I wanted to do this 3 times. So in order to do it 3 times, I would have to basically copy paste it 3 times, right? For it to run 3 times. But there's a better way to do this. So we'll delete these lines, we'll take these and move it down, and let's put these in a function. So we'll indent, and then I'll create the function by saying def, the function name, and that's it. Now down here, I'll create a for loop for I in range, and I want to do it 3 times. So I'll just give me a range from 0 to 3, and then within it I will call greet. Okay, let's try this out. What is your name? I say Anthony. Hello Anthony, how are you doing? What is your name? I say Anthony. Hello Anthony, how are you doing? Anthony again, and there you go. It runs 3 times. So let's break down the structure of this. So for a function, this keyword, I don't know what the proper term is, but def is short for define. So over here I'm defining the function. Then I give the function name, and then I do open, close, parentheses. And then with indent, just like here for this for loop, I indent, letting Python know everything indented after this line is part of the function. And then I just do like we've done before, where we get a name as the input and then we print it. Here in the for loop, to call the function, I give the name of the function and then open close parentheses. We can go about this another way. We see here I have the input inside the function, but what if I want to take it out of the function and have it here in the for loop and then pass the name we're given into the function? We can do that with arguments. So here when I'm defining the function, I'll say name is an argument for our function, and then this name here refers to this here. I'm telling the function use the argument called name that's given to us. So I'll change this just to avoid confusion. So here in the for loop, person is the input we get, and then I'll call greet and pass person into our greet function. Let's run it. There you go. What is your name? I'll just say ANT, and then it's working just as before. Up here, when we're defining the function, name is a parameter, and you can see it here in this little pop-up window. When we call the function, we use an argument, saying the argument, I guess, for the function is person. So up here, parameter, and then when you call it, it's called an argument. But they're sort of used interchangeably. Within our function, we have it doing a print statement, but we can also return something. So when we call the function, it returns a value, whatever we want it to do. Let me give you an example. So let's delete all of this. and we'll make a function called add, and it'll take, well, its arguments, or my bad, see, I used it interchangeably. Its parameters are number 1 and number 2, and we'll say return number 1 plus number 2, and here we'll do print, and then within our print we will call the function add, and we'll give the arguments 5 and 2. So we're calling the function add using arguments 5 and 2. They'll get passed into this function here is number 1 and number 2, and we return adding them together. Let's see what happens. And we get 7. Since we have this return here, when we call the add function within our print statement, this value is essentially returned to us. So within here, it becomes this 7. Now it's print 7 within our print statement, and 7 is printed. Quick visual explanation of what we just saw. So here we have the same code defining our add function with number 1, number 2 as parameters. Then within our function we return number 1 plus number 2. Below that we have our print function, and within the print function we are calling add with 5 and 2 as arguments. So let's see what this means when we call a function. Let's take a copy of our function to the right, and within our print we are calling add with 5, 2 as arguments. So we're essentially passing 5 and 2 into our add function. Well, if you compare the function on the top left with the add 5, 2 we have on the right, 5 is in the number 1 spot, 2 is in the number 2 spot. So essentially 5 is number 1 and 2 is number 2. That means that in our return statement we just have 5 plus 2. 5 plus 2 is 7. So our whole function sums down to return 7 when calling add with 5 and 2 as arguments. We then return this back to our print statement, and we have print 7, thus 7 gets printed. For arguments, there's different types of arguments for a function. There's positional, default or optional, and then keyword arguments. Let's see an example of each. So let's go with positional first. So I'll change this name to subtract, right? And then I'll say return number 1 minus number 2. We'll change the name down here, subtract, and we'll run it. So I have 5 and 2 as arguments. 5 is number 1, 2 is number 2. We're returning number 1 minus number 2. So 5 minus 2, we should get 3. 3 is what we get. But now let's switch them. So instead of 5 and 2, I'll keep the same numbers, but I'll switch their positions and say 2, 5. Now we get -3. These are what's referred to as positional arguments. And this is the default styling whenever you're defining a function. We're saying the first argument that you give when you call the function is number 1. The second argument is number 2. If we were to add another one, the third would be, and then whatever we give the name of it. Positional arguments are required whenever you call the function. For example, instead of 2, 5, if I only just gave 2 and tried running it, you see we get an error. Subtract function missing 1 required. See, positional argument, and then it gives the name of our argument that we're missing. After positional arguments, the other type is optional or default arguments. Let's take our subtract function, and for number 2, I'll say number 2 equals 0. Now remember before when we tried running our subtract function with just 1 argument, we got this error down here saying it was missing 1 required. But now that I put number 2 equals 0, I've given it a default value. So now the second argument, or number 2, is optional. Let's run it and see. And look at that, we get 2. So now 2 is number 1, and number 2, I gave it a default value of 0. So if when calling the function there is no number 2 argument, Python knows, okay, this value has a default value of 0 if nothing is given. If we give it a number, we'll say 1, and then we run it, you see now I get 1. 2 minus 1 is 1. That was a default or optional argument, and those must come after our positional one. Next, we also have keyword arguments. Let's delete this. So now number 2 is a positional argument again. And here we said whatever we put in this first space is number 1, and then the second argument we give is number 2. But using keyword arguments, you can call the function and give arguments in a way where it doesn't matter which position they're in. So here, if I do 100, no, we'll do a smaller number first. 1 minus 100. We have number 1 as 1, number 2 as 100. So we run it, we should get negative 99. But let's say I specify that number 1 is the number 1 is the number 2 argument. I'll say number 2 equals 1, and then I'll say number 1 equals 100. And look at that, I now get positive 99. Because when I'm calling the function, I know the names of the parameters, and I can tell Python, this may not be the correct order, but I want number 2 parameter to equal 1, and I want number 1 parameter to equal 100. That's keyword arguments. Within our subtract function, we've defined 2 parameters, number 1 and number 2. So that means whenever you call the function, you can only give 2 parameters. But what if we don't know how many arguments the user is going to give us when we call a function? Say we have a pizza maker program, and we want to give the user a alert or some way of knowing that the toppings that they requested have been added to the pizza. At first, we don't know how many toppings they're going to add. They can just be basic like me and have just pepperoni, or they can have pepperoni, jalapeno, sausage. Within Python, there's a way to have sort of an arbitrary number. I think that's the word. Arbitrary. An arbitrary number of arguments into a function. Let's see how to do it. So I'll change the name of our function to go with what I was just talking about, and say pizza maker, and say topping, and then print the topping they gave us was added to the pizza. Exclamation point, because we're excited about making the pizza. Now here, I'll call the function, and I'll give it just cheese. So let's run it. There we go, cheese was added to your pizza. But now if I want to add pepperoni or sausage or pineapple, if you like that stuff, I have to change the definition of our function, as well as this print statement has to get a little weird. But there's a way to, like I said, have arbitrary number of inputs, and all it is, or arbitrary number of parameters, and all it is adding a star. So now I have this star in front of our parameter, and that tells Python all the inputs or parameters that the user gives us, make a tuple out of them. And if you remember tuple, it's just a list that can't be changed. And now the user can give as many arguments as they want. Let me show you what I mean. So first we'll change our function a little bit, and I'll say for topping in toppings, and then we'll move this inside our for loop. We want to print topping was added to your pizza. And remember, with this for loop, this takes this value or item, the name that we assign here, takes on the value of each element in our list, or tuple in this case. Now down here, let's go ahead and print or give a lot of toppings. Cheese, pepperoni, jalapeno, sausage. I think this is what's called a supreme pizza. I don't know. Black olives. I don't think those actually have any flavor. And that's it for now. Let's run it. Look at that. Cheese was added to your pizza, pepperoni, so on and so forth. All of the arguments we gave it were added to our pizza. Now that's using what's called an arbitrary number of arguments. We can pair, I guess that's the right word, where we'll have the first argument they give us is a positional argument, and then anything after that first positional one, we're saying assign it into the tuple of toppings we have here. So for example, I can say the first argument is size, the size of the pizza, and then we'll print with an F string whatever size they give. Pizza is being made. And now down here, I'll add the size of our pizza. I'll say large because I'm hungry. And let's clear this and print it or run it to see what it looks like. I mean, look, there we go. A large pizza is being made, and then all of our toppings. Now when I define the function, this first parameter is a positional parameter, and then it tells Python after this first one, anything the user gives us, assign it into this toppings tuple. If you remember earlier, we said when calling a function, we can use keyword arguments. The example was we had the order switched, but we told Python that number 1 was equal to 1, or number 2 was equal to 1, and number 1 was equal to 100. The same logic applies here with keyword arguments, where we can get a arbitrary number from the user. And it kind of works the same way as with this tuple of toppings, but instead of just a single star, it's a double star to signify to Python that is a arbitrary number of keyword arguments, and Python will take those values and assign it to a dictionary within the function that we can use. Let's see an example. Let's make a better version of our greet function earlier. So we'll say we'll define a function called greet person, and we'll use an arbitrary number of keyword arguments. Then we'll say for key value in kwargs or keyword arguments dot items. Now real quick, this dot items is a method. Since we're using this annotation here, ** keyword arguments, that tells Python that all the keyword arguments that are passed into the function make a dictionary out of them. So now keyword arguments is a dictionary, quote unquote, and dictionaries in Python have methods like all the other objects in Python, and one of the methods that dictionaries have is this .items function, and that's just getting the items, the key values, out of the dictionary. That may have been a little advanced for what we're on, but we'll discuss it later when we get to classes and objects. But we'll print with an f string, because I like f strings, I guess. Hello, and then the key they give us, and then we'll say you are, and then the value, years old. Now let's call our function. We'll say greet person, and we'll give a random number of keyword arguments. The first one, Alice, equals 24. The next one, we'll say Bob equals 25. Charlie, 27. Oh, 27. And then I'll include myself, like M. Night Shyamalan, however you say his name. Okay, now let's run it. And look at that, there we go. Hello, the name, and then their age, or the key that we gave, and the value. And this for loop here works the same as all of the other for loops we've done before, where the key takes on the value within our keywords dictionary, and then the value takes on the value. Just like with the arbitrary number of parameters or arguments, we can also pair a positional argument onto this, or positional parameter. So we'll say the first two arguments that are passed are name and age, and then anything after that we'll assign to a dictionary. So I'll change our function a little bit, and we'll change it to profile builder. That's the name of our function now. We'll print hello, give the name, and then here is your profile. Right under it we'll make a dictionary called profile, and for the first key value pair we'll give name and then their name, and for the next one we'll give age and then their age. After that, every key value pair they give us we'll just add to our dictionary by saying profile key equals value, and then at the end we'll print the profile. Okay, so let's call our function profile builder. Up here, since we've defined the function, it knows which parameters are needed. So first one, it tells us name, then age, and then we have kwargs, or an arbitrary number of keyword arguments. So for the first, we'll put the name, and then the second one, age, and then we'll give some keyword arguments. Hobbies equals, and then give just a quick list of hobbies. We'll say occupation, engineer, and we'll leave it as those two because I can't think of anything else. Okay, let's clear this and then run it. Hello, Anthony. The first argument I gave it, here is your profile, and then it made a dictionary out of everything I gave it. First was the name, Anthony, then the age, and then the rest of this was the keyword arguments, and I'm realizing now that I spelled basketball wrong. Now you can have all three that we just saw in a function when you're defining it. You can have two positional ones, then take an arbitrary number of arguments, and then take an arbitrary number of keywords. As long as when you're calling the function, I guess you remember how you defined the function. But Python or VS Code is pretty good about that, letting you know you define this function, here's the parameters that are needed for it. While we're on the subject topic of functions, we can discuss local versus global variables. Let me show you what I mean. So let's go back to a function sum, and we'll just add a number they give us plus another number. So we'll say sum x, print x plus y. Now up here we will say y equals 10. Oh, I should put this in parentheses. And then we'll call the function and we'll give it a value of 10. Let's run it and see what happens. There we go, we're given 20. Now this is because when we wrote our y variable out here, it's defined as a global variable, and we're able to access it within the function. Global variables basically mean any function, line of code, class, whatever, is able to access it. Let's try defining a variable within our function. Within it, we'll create a variable named z, and we'll say it's equal to 20. We'll print x plus z, and let's see what happens when we run it. Now we get 30. But out here, let's try printing y and z. You see we get an error. Name z is not defined, and if you saw it before I even ran it, there was this squiggly line with VS Code telling us that z is not defined, even though we have it written here. And that's because this is a local variable. Since we defined it inside a function, z is a local variable, so only code within the sum function has access to that variable. Onto probably one of the most confusing topics for me, I think. It's called recursion. So recursion is basically just when a function calls itself within itself. I guess if that makes sense. The function calls the function within the function. Let's see an example. Maybe explain it better or just confuse us more. So let's make a function called sum integers. And what this function will do is we'll give it a number and it'll return a sum of all integers before that number. So if we give it 5, it'll give us 5 plus 4, 3, 2, 1. Our parameter is in. We'll check if in is 1, return 1, else return, and then we'll call our function within our function in plus, call our function sum integers in minus 1, and that's it. That's the recursion. Now we'll call our function and say print sum integers 5. We need one we can do in our head or with the calculator easily. So if we give it 5 and we're adding all numbers including 5 before 5, 5, 4, 9, 12, 14, 15. I think we should get 15 unless I'm adding wrong. Let's run it. Look at that, 15. Now let's see if I can explain how this works. For that, I'll use, I think, a fancy tool in VS Code, Python debugger. So this drop down arrow here, Python debugger, debug Python file. So in order to run the debugger, we need to give it a breakpoint. Basically, tell VS Code when to stop. Otherwise, it'll just run straight through the code. So over here on the left, you see you can click to add breakpoint. I added it down here because I wanted to stop on this line. Okay, let's go through our debugger again. And there we go. It's highlighted the line of code that we're currently on. Print sum integers 5. I'll hit this down arrow to go into this function. And now here we are, the first line. Over here we have in equals 5. This is what we called for our function. This was our argument, in is 5. It checks is in equal to 0. We know that's false. So it goes to our else statement and says return in plus, and then it calls the sum again with in minus 1. So let's dive into it. We're now a level inside of our function. So we're one or two levels deep. Over here on the side, we have what's called a call stack. Then we called our function, and now we're within our function. One level within. It's like this is going to be like Inception. So now here, look, our in changed. It's now 4. In is still not equal to 1. And then it'll just go again. Now in is 3. Still not equal. Go further in. We're really going real deep into this. Maybe I should have picked a smaller number. In is 2. Okay, now in is equal to 1. It checks this. This is true. Goes to the next line. And it returns 1 value. Or value of 1. And this is the line that we're on right now. So now, when in was 2, we're saying plus sum integers 2 minus 1, or some integers 1. So now right here we return 1. 1 is returned, so now this is value of 1, and we have 2 plus 1. We'll go ahead and go next, and now we have in is 3. That was the 2 plus 1. And now we're just falling back out of the function, going up the levels. First we were going down into the function, now we're coming up and out. And we'll see here, we'll just keep adding it and adding it until we get out. I know that's definitely going to need a visual explanation. And here it is. We have our sum integers function using recursion, and then we have our print function, and within our print function we are calling our sum integers function with an argument of 3. I use 3 instead of 5 because it's way faster to animate than 5. Alright, let's go ahead and dive into it. So from our print function, we call sum integers. So here we have a copy of sum integers function, calling it with an argument of 3. Let's go ahead and plug in 3. Then we go to this first line, if n equals 3. We're comparing our functions top left with our sum integers function we have now. 3 is in the place of n, so 3 is n. We plug in 3 for n. If 3 equals 1, we know this is false. So we come on down to our else statement, run the code within the else statement where we return n plus some integers n minus 1. As we said, n is 3, so we plug those numbers in. And now we have 3 plus some integers 3 minus 1. 3 minus 1 gives us some integers 2. So now we're left with this return statement, but we don't know what sum integers 2 is. So we call sum integers again, this time with an argument of 2, but leaving our sum integers 3 somewhere on the back burner, somewhere in memory. We're now on sum integers 2. Again, we run the first line. 2, n is now 2. We plug this in. If statement is still false, come over to our else statement, and then again we run our return statement and plug in 2 where n is, and we're left with 2 plus some integers 2 minus 1. 2 minus 1 gives us 1, and we still don't know what sum integers 1 is, so we call it again, this time with an argument of 1. Now we run our if statement again. This time n is 1, so this if statement is now true, and we go into the if statement and return a value of 1. This if statement here, if 1 equals 1, is what's known as a base case. It's what allows us to break out of the recursion. If it were not for this if statement, then we would again pass 1 to n, and then we'd have 1 plus some integers 1 minus 1. And this would just keep going on infinitely. We would keep going further and further into this infinite inception thing. But we have our base case, so we return 1. Let's start backing out, and we have sum integers 1 just sums up or boils down to return 1. Let's start backing out of this recursion, and we last left off sum integers 2 at this return 2 plus sum integers 1 statement. We now know that sum integers 1 returns 1, so we plug that in, and we're left with return 2 plus 1. 2 plus 1 is 3. Now we can start backing out of this sum integers 2 statement. We left off sum integers 3 with return 3 plus sum integers 2. Well, we just figured that out. Sum integers 2 returns 3, so we plug that in, and we're left with return 3 plus 3. 3 plus 3 is 6. Now we can back out of all of our sum integers functions and return to our original print function where we called sum integers 3. Then we return a value of 6 to our print function, and 6 gets printed. Hopefully this was a way better explanation visually seeing it. Just remember, with recursion, all recursion is calling the function within the function. But you need a base case to break out of this recursion, otherwise you would infinitely go down the rabbit hole. For the first exercise, we'll create a function that will determine if the first number they give us is evenly divisible by the second number we're given. Let's try it. Let's make a new file. We'll call it exercises divisible. Alright, let's make our function. We'll say is divisible. We'll have our number and then I think it's a divisor, the thing you divide with. And we'll say if number modulo divisor is 0, aka there's no remainder when we divide the two numbers, return true, else return false. Now let's make an if statement. If is divisible, let's give some numbers. I know this trick in math that I learned. So 1 2 3 4 5 6 5 4 3 2 1, and then we'll say 1 2 3 4 5 6. I think that's divisible. We're about to find out. If is divisible with those two numbers, print, and then we'll say, and then we'll just give our numbers. Let's make this even easier or more efficient. We'll get numbers from the user. We'll say num1, and then we'll give it an integer input, and then we'll get number 1, and then we'll get number 2. And then here we can just put num1, num2. And then within our print, number 1 is divisible by, and then the number 2, and then we'll just show what it is. Else if it's not, we'll just print nope. Alright, let's try it. Number 1, start with something easy. 10 is divisible by 2. There we go. 10 is divisible by 2, it's 5. Let's try the really big number that I had. 1 2 3 4 5 6 5 4 3 2 1 1 2 3 4 5 6. Yeah. I don't know how to say that number really quick, but this number is divisible by this number, and it is this number. Let's go through the exercise real quick. So we made the function is divisible. Our parameters are number, divisor. We check with this if statement if number basically is divisible by divisor. If it is, when we do this modulo, our remainder should be 0. Therefore, we return a true statement that the number is divisible by the divisor. And if it's not, then we return false. We get our input from the user for number 1, number 2. Then we have this if statement where we call the function and it'll return true or false. And if it returns true, we print this statement with their number 1, the number 2, and then show what the multiple is or what the answer is when you divide the numbers. But if it returns false, then we just print nope. Let's give an example of something that would be false. So 5 divided by 2, it just says nope. For our next exercise, let's try to replicate the Fibonacci sequence in Python. If you're not sure what the Fibonacci sequence is, I don't know if it's that spiral thing, but basically it's a sequence of numbers where the first two numbers are 0 and 1, and then every number after that is the sum of the previous two numbers. Let's do it in Python. It'll calculate it way faster than us. So let's create a new file. We'll call it exercise Fibonacci. So we'll define our function. We'll call it Fibonacci, and the parameter will be in. We'll do our base case as if n is equal to 0, we return 0, and our other base case if n is equal to 1, return 1, else return, and then now we'll do recursion Fibonacci in -2 plus, call our Fibonacci function again, in -1, and that's it. Let's print Fibonacci, the 5th item in the Fibonacci sequence. We get 5. Instead of doing that ourselves, let me see if I can find a list of the Fibonacci numbers. So I found this image, and you see terms are numbered from 0 onwards. So we start at 0, we go to our 5th term, and it is 5. Fibonacci works. For the project, we'll add a little twist to the calculator we did in the last video, to where they can do one operation, but now they can do that one operation on as many numbers as they want. Let's try it out. So we'll make a new file, and we'll call it calculator upgraded.py. And let's begin. We'll define our function as calculator. The first argument or parameter, since we're defining it. We'll give a default value of plus, and then we'll have an arbitrary number of arguments, and we'll just call them numbers. So now we'll say for number in numbers, and this may not be the best way to write it, but hey, we're still learning. So we'll make a variable called answer, and we'll give it 0. Then we'll check the operation they give. If operation equals plus, we'll add each number to our answer. Else if operation equals minus, we'll subtract all numbers. Now if their operation is multiplication, we'll have to change answer to a starting value of 1, because if we begin it at 0, everything multiplied by 0 is 0. So we'll add here just the if statement. If operation is multiplication or division, then our answer will start at 1. Then we'll come here and say answer times equals the number, and then the other one will be division. Like I said, this is maybe not the best way. 100% probably isn't the best way to write this, but we're still learning. So let's call, or actually let's go ahead and get an input. We'll say op is the input, or actually no, we'll do one better. Let's just call the function. Calculator, we'll first do addition, and then we'll give a lot of numbers. Ones we can add, 1, 2, 3, 1, 3. So that's 1 plus 2 is 3, plus 3 is 6, 7, 10. Now let's go ahead and print it, and at the end we'll return answer. I almost forgot that. Alright, fingers crossed. 10. Nice. Let's try switching it to multiplication. So let's see, 1 times 2 is 2, times 3 is 6, times 1, 6, times 3 is 18. Let's try it. 18. Nice. This project may not have been the most challenging, I guess, but even the little ones help. Well, that's it for today's lesson. I hope you enjoyed the video and I hope you learned something. In the next video, we'll discuss modules, which help us write all of our functions in one Python file, and in our main Python file we can call those functions into it. That way our main Python file is a little cleaner. I'll see you in the next lesson.